All right, well, thank you for the invitation. Apologies for the mask. There's someone working here in the house. So I'm going to begin with the same slide that Leanne began with. So I'll move through this fairly quickly, and I imagine that Hugh might be doing the same. So yes, the low accuracy issue, of course, we're aware of, and training doesn't really seem to help all that much either. This is a fairly classic effect at this point. And to make matters worse, as I'm sure we're aware, we tend to be biased to guess other people are telling the truth rather than think maybe they're lying to us. And we call that the truth bias. And so given this low accuracy, that we can't seem to make ourselves any better at this, not much anyway, and that we take at face value what others say, it's quite reasonable to say, well, perhaps what's happening here is something that's built into me as a decision maker, some sort of cognitive bias that's pushing me to make the wrong judgments. What the adaptive lie detector account argues, does that look black to you? Because that looks black to me. Yes, it does. Hold on. Aha, okay, here we go. What the adaptive lie detector account argues is something different. It takes a slightly more optimistic view of our abilities. And it says if there are cues about this specific statement that are quite reliable, we can make use of those to inform our judgment. So think of Pinocchio's nose, for instance, or if I claim I went to France last week and there's CCTV footage of me being in France, then that's a very reliable piece of information about this statement specifically. And you could use that to inform your judgment. Unfortunately, we're often not in that position. And our participants certainly aren't. They're in a lab, they're asked to make a judgment from a video with passive behaviors. And so a liar looks just like a truth teller to them. So what are they to do? Do they guess randomly? Well, they could do, but what I've been arguing is that as these cues about this specific statement become less and less reliable, we rely more on information that generalizes across statements rather than being specific to the current statement. So we're trying to fill in this gap in our understanding about the current situation by informing it with our knowledge of what tends to happen in statements. And what tends to happen? Well, most people tend to tell the truth most of the time, as we see in a variety of diary studies that replicates. And so ALIED, for short, the adaptive lie detector, says the low accuracy isn't an error or something that we're doing wrong. The low accuracy results from liars just being very good at what they do. They don't give themselves away very clearly. And when we don't have good information, it makes sense to guess someone is telling the truth in certain situations. And that is why we see the truth bias. And given that our contexts don't really change across most of our experiments, this is why we so often see the truth bias. Now, this account, as I've just very briefly outlaid it there, is a verbal account. And what I mean by that is that it's rather loosely defined. So when I talked about those two bits of information we use, I don't really explain in any way how memory comes into play, how visual perception comes in, how we perceive things in the world, how our goals drive the way we think. These are all very basic cognitive mechanisms. And by cognitive, I just mean how we think, right? So these are all basic cognitive mechanisms that we're fairly sure exist. For many years of research have been done on the existence of memory and how we learn information and whether rehearsal will create that information to be stronger in memory and the decay rates that we can mathematically model and all the rest of it. So we're trying to tighten the ALIED account by using a computational architecture that's built up with 40 years or more understanding of basic cognitive mechanisms like memory. And we've tried to instantiate ALIED within this framework and to allow decisions to naturally fall out of this mechanism. So what does that look like? I'm going to give you the very broad picture. We're not going to talk about the formulae and all the rest of it. So in memory, you will have an experience of a cue, let's say eye contact. And you'll have two memories for that particular cue. One is this cue, eye contact, is associated with deception. That's one memory or one chunk. And the other is eye contact is associated with honesty. So you have these two chunks of information in memory, and you're going to try to recall one of them, whichever is the most active in memory. And the reason for that is that the most active one is the one which will have been perceived most frequently. So frequency of observation increases activation in memory. Think of rehearsal. Right? The more often we repeat something, the stronger it becomes in memory. And so our decision is simply a memory retrieval issue. as far as this account goes. And it's based on something called instance-based learning theory, which I won't be discussing, but instance-based learning theory has been applied to many different problems. And so we're constraining ourselves to the same predictions as that account. Now, in this case, the Q is equally associated with deception and honesty. The memory activation is the same. And so you'd randomly guess in this situation. However, as we've been saying at the start, when you don't have good information about this specific statement, that is when the Q is not reliable, we rely on context information. So the function of context is to adjust that activation information. On the left here, I don't know if you can you see my mouse? Someone give me a thumbs up. Yeah, I can see some nodding, great. So on the left here, when the context is such that most people will lie, what happens is that the memory for truth-related information is penalized. So anything that contradicts the current statement, the current context, becomes penalized. And as a result, the lie Q is the most strongly activated in memory, and we retrieve that. So in this case, we're retrieving a Q that says this person is lying, when the context is such that most people lie. And on the right-hand side, we can see the exact same, except in reverse. The context suggests most people will tell the truth. We're going to penalize anything in memory that's contrary to that, and then try to retrieve from memory the most active information, and that will be a truth. So in this case, we'd make a truth judgment. So here you can see the importance of context when we have an unreliable Q, that is, a Q that is equally active when someone's lying and telling the truth. That works differently when you have a highly reliable piece of information. Think Pinocchio's nose. On the right-hand side is the most interesting one, so I'll focus on that. So when we think that most people tell the truth, here we have a highly diagnostic piece of information. Very reliable, says someone is probably lying. We penalize that because it's contrary to the current context. But despite the penalizing effect, it's still the most active information in memory. That is, despite the fact that most people lie or tell the truth in this situation, Pinocchio's nose grew. It is a reliable piece of information. And so that still ends up being the final decision. So in this case, when you have highly reliable information available to you, the context doesn't really affect the outcome of the judgment, even though it is having that same penalizing effect. The same mechanism is occurring, but the judgment outcome is different. So with a highly reliable piece of information like this, the context has no bearing on the final decision, ultimately, whereas when it's not reliable, it has a very important bearing on the decision. Now here we're looking at some behavioral data we collected around 2016 or so. And on the x-axis, we're looking at a Q that specifically relates to this statement. And in the middle, we have the most unreliable behavior. And as we move out towards the edges in each direction, we move towards more and more reliable cues about this specific statement. And the bars, the two bars here are representing two different beliefs. One is that most people tell the truth in white. So these people in the white group believe that most people are going to tell the truth. Those in the gray bars here think that most people are going to lie. And ALIED predicts that when you have highly reliable cues, the effect of context will be very minimal. That is, this gap here is very little. And the gap that's representing the proportion of truth judgments. How often do they say truth? And we see the same on the other extreme. And it's only as we come towards the middle here that we see that people become lie biased when they think most people will lie, but there's an unreliable cue, or truth biased when they think most people will tell the truth. So context has this substantial effect when there is no reliable information, but when there is reliable information, the context doesn't have that much of an effect. And the line we're looking at, that's the model, that's the ACTAL model we've just been talking about, and that's it performing. And down in the bottom here, you can see the R-square fits and the error to the behavioral data, which is fairly tight fit to that data. Now, the most important thing that I want to take away from this talk is not that it's meeting the data, it's that it's producing predictions. So one prediction that comes out of this model, for instance, is what happens when people learn the behaviors in the first place. How do they go about that learning? And a natural result of this memory retrieval process and other non-linearities in the mathematics result in this S-shaped curve here. And what this means is that when you have a cue that is present 70% of the time when people tell the truth, they don't make 70% truth judgments as they're learning. They actually overestimate that. They make more than that. And this is a behavior called maximizing. And the same happens in the other direction. They make fewer truth judgments than the behavior suggests. Or to put it another way, they guess a lie when more often than it actually is associated with deception. So here is the prediction. Now, in the original study, we didn't collect the learning data. So we had to run a new study, and that's why the data looks a little different here. But you can see there's a relatively good fit of the model, and this model is not fitted to this data. It's a natural prediction that came out of the other data that we used for. And you can see it's a fairly nice fit. Apologies, I don't have the R-squareds at the moment. This is a paper that's currently in prep, but you can see it's doing fairly well at explaining how people learn this information as well. Now, there's a variety of different predictions. I'm not going to walk through all these, don't sweat it. They're just here to give you a sense that ALIED produces a whole set of different predictions. And in the top here is, I think, possibly the most controversial one. There are others down here which are about reaction times or how information is integrated and so on. But this top one, I think, is perhaps the most interesting, because those who perhaps subscribe to a more cognitive default position that you can't help but believe might argue, and I don't want to put words into people's mouths here, but may argue that there isn't much evidence that we can be biased to disbelieve others. And I agree with that. There isn't much. There is some, and that's what we're seeing here. That's what these citations are. They are evidence that there are sometimes lie biases around. And importantly, ALIED also says that a lie bias, a bias to disbelieve, is exactly the same process as a bias to believe. Those two things don't arise from extra steps. You don't need extra processes to get to a lie bias. It's exactly the same process. There's just different beliefs about the context or about the availability of information in the world. It's not me as the decision maker that's changing. So yes, I think this prediction is still up for debate, as are pretty much all of them on this list here. As you can see, I don't have many citations for any of them, really. So the real benefit here, and the key take home I want to deliver, is not that ALIED is right. In fact, me and Victoria Talwa are currently working to try to show that it's wrong. But the real benefit here is that it produces predictions. And if you disagree with this perspective that it's adaptive, great, all the power to you. And I hope you'll go out and try and test these predictions and show it to be wrong. But the real strength of theory comes from the possibility that it can be shown to be wrong. And that's really the strength of this account. Thank you very much.